This is Algebra 2 with trig. We're working on Unit 2A.1. A few things that we're going to identify is what is a polynomial and what is not a polynomial. So there's a few characteristics. A polynomial is not going to have negative exponents. A polynomial equation is not going to have an x in the denominator, which is another characteristic of a negative exponent. What you are going to have are integers for exponents, no fractions, no decimals. When we look at this side, we're not a polynomial equation. It's not in standard form because the x squared is not written in the correct order. You need to go with the highest exponent first and then decrease all the way through. That's how you write it in standard form of a polynomial. We have our different equations. We have a linear equation where it's x to the first power. We have a quadratic, which we've gotten done doing a lot of lessons on quadratics. We have a cubic, which is to the third power, and a quartic to the fourth power. And this little chart is showing that you cannot divide by a variable. You can't have a negative exponent, which again is going to imply that it's in the denominator. You can't have a fractional exponent or a decimal exponent. And it's a funny term, but you can't have an infinite number of terms. It has to be at 3 terms, 4 terms, 5 terms. It can't be an odd equation that just goes on forever. So let's look down at a list here. We're going to decide which of these are polynomial equations. And if so, we're going to write it in standard form, and we're going to state the degree. Well, I see here we have a fraction as our exponent. Well, that's one of the characteristics we can't have. Here it showed a decimal. You can't have a decimal as an exponent. The same thing as you can't have a fraction as an exponent. So this fraction would imply that it's the square root of x. It's a fancy way of writing a radical. So this is not a polynomial. This one here. Here we have negative 8, which is okay. X to the 5th looks good. 4x squared. We have the square root of 10, but that's not the square root of a variable, so square root of 10 is okay. And x to the 4th. So this is a polynomial. Now we need to write it in standard form. That means your largest exponent has to go first, which it currently is. Then your next largest, and negative 4x squared. And then finally end it with the square root of 10 at the end. This final one here, if you notice, there is a negative 2 as an exponent. So that indicates that this is not a polynomial. Now, when we work with polynomials, one thing that we can do is evaluate for a certain value. It happens a lot with graphing. We want to plug a number in to figure out where it is, the y value. Direct substitution is what we're used to. We might call it f of 2. That's telling us that we're going to plug a 2 into our equation. So in this case, it would be 2 cubed and 2 squared minus 12 times 2 minus 5. So order of operations tells us that we need to do our exponents first. So this becomes 8, 4, negative 24, minus 5. Then we multiply to get negative 24 plus 4. This would be negative 29. So this would be negative 20, and negative 29 gives us negative 49. So f of 2 is negative 49. Now let's try a different method. We're going to try what's called synthetic substitution. Next, we're going to try synthetic substitution. In the book, there's a bit of an instruction on how to do that, but I'll go over it right here. It's pretty simple. Look at all these different steps that we have to do for direct substitution. You got to remember your order of operations. You got to do some calculations. Sometimes they can get pretty big. Here, with synthetic substitution, what we're going to do is write down all of our coefficients. So negative 3, 1, negative 12, and negative 5. It's kind of looking like division, but we're going to draw this bar a little bit backwards. And here we know what x equals. That'll make more sense in the future, but we know what x is. X is 2, so we're going to substitute in our 2. To do synthetic substitution, we drop down our negative 3. Then we multiply. We get negative 6. Then we add these together to get negative 5. And you multiply over to get negative 10. You add these together, get negative 22, multiply to get negative 44, and look what we get, negative 49. Notice that this problem was the same as what we did the first time. With the same x, the same problem, we did it with direct, and we did it with synthetic substitution. Now the tendency is a student saying they don't want to learn something new. You're going to need to use this. So don't be afraid. Write down your coefficients, drop down the first number and multiply. Place it underneath the second one. Multiply, place it underneath. Multiply, place it underneath. You just keep grouping them up as you go down. Okay, here's this one. This has a little bit of a trick. You really have to pay attention. This is a 4. This is a 3. This is a 2. But there is no x. But we have to put in a value for the x. So when we put in our coefficients of 1, 2, 3, 0 for your x value, negative 7, put the negative 2 as the value that we are substituting in. So you gotta have that place value holder. We drop down the 1. Then what are we gonna do? Multiply, add them together, multiply, add them together, multiply, add them together, and multiply. So f of negative 2 is going to equal 5. Over here we could say that f of 2 equals negative 49. Here we have n behavior. Now we're pretty familiar with some n behaviors. We've done n behavior in the past. Now what we're going to be looking at here are some patterns. We're not going to be specific about the equation, but we can predict what the n behavior is. So for example, if the degree was odd, an odd degree, so you could say that a linear equation is odd. You could say a cubic with 3 separate zeros is going to be odd. Notice what happens. It's pointing down to the left, it's pointing up to the right. So as x approaches positive infinity, if you have an odd degree and a positive leading coefficient, then the y value is going to be positive. It's going to approach positive infinity. And if we look to the left, to negative infinity, we see that the y value drops. It goes to negative infinity. So odd degrees go in opposite directions. Now if we have odd degree, but we have a negative leading coefficient, you know that a line with a negative slope is going to fall to the right. Well, the same thing's true with the cubic equation that would have 3 separate zeros. It's going to fall to the right. So this is going to be true for any odd degree, to the first power, to the third power, even to the fifth power. The pattern's going to be the same. It's going to fall to the right, it's going to end going up. So as x moves to the right, you're going to see that the y value decreases. And as x approaches negative infinity, moves to the left, we notice that the graphs all head upwards to positive infinity. So those are the only situations that we have for odd degrees. An odd degree is going to increase to the right and fall to the left if it has a positive leading coefficient. It's going to fall to the right and go up if it has a negative leading coefficient. That's an extra negative. That's what makes it flip and end up going downwards. Okay, let's talk about an even degree. That is a positive leading coefficient. What type of function do you know has an even degree? You know that a quadratic is an even degree. And that's going to be true about any even degree. Second degree, even fourth degree would cross and have 4 touching points on the x-axis. It could. But they're both going to be pointing upwards. So as x moves to the right and you have a positive, you are going to get a positive infinity. The difference, what we see here, is that with an even, they're going to always point in the same direction. But in the odd, they pointed in opposite directions. If we have an even degree that has a negative leading coefficient, the one that you're most familiar with is a parabola. You know that when you move to the right for x, the parabola is going to drop. If it has a leading coefficient that's negative, it makes it open downwards. So it goes to negative infinity. As you move to the left, the function's also going to go down. So the patterns that we're seeing here is that when we have an even degree, 2, 4, 6, and a negative leading coefficient, we can predict, it doesn't even matter what the numbers are, we can predict that it's going to fall to the right and eventually fall to the left. Same thing's true for an even with a positive leading coefficient. It's going to go up in both directions. With an odd, it's going to go in opposite directions. A positive leading coefficient goes in the positive directions to the right. And a negative leading coefficient always goes negative to the right. Last page. So what are the end behaviors here? Well, let's take a look at what we have. We have a degree of 4. The degree is 4. More importantly, it is even. It's an even degree. The leading coefficient is negative. So what I would expect here is that it's going to cross maybe 4 times. That's the most it can cross. Because it's negative, it's going to be falling to the right. Because it's even, it's going to be going in the same direction. Now the rest of the time, it just kind of wiggles its way through. We'll learn more about how it goes through. All we're looking at here are the end behaviors. So as x approaches negative infinity, the function goes down. As x approaches positive infinity, the function also goes down. An even degree, they're going to go in the same direction. A negative leading coefficient is going to fall to the right, so it has to fall to the left. Here we see that it's written in standard form, 3, 2, 1, and your constant. So we see that the degree, more important than the 3, the more important is that it is odd. And the leading coefficient, more important than it just being a 1, what we need to know is that it is positive. That means this graph could cross 3 times. We'll talk more about that in the future. But it is going to increase to the right. That's what a positive, you'll have more positive numbers. So when you multiply them together, they're going to go to a positive direction up. Positive y. Positive x's make positive y's. So as x approaches negative infinity, our g of x, negative infinity is to the left, our g of x falls, goes to negative infinity. But as x approaches positive infinity, g of x is going to go up to positive infinity. An odd degree makes them go in opposite directions. If it's positive leading coefficient, it's going to increase to the right. Therefore, it has to decrease to the left. Because you know it's an odd degree, it's got to go in opposite directions. Let's take a look at this little chart. What pattern do you see with degree 2 and 4? 2, they're heading in the same direction. That's a parabola. We're very familiar with that. 4, they're also heading in the same direction. We would expect this to have a positive leading coefficient because it's going up. Positive leading coefficient because it's going up. This would be a degree of 1 because it's linear. But notice they go in opposite directions because it's odd. Odd, it goes in opposite directions. Odd, it goes in opposite directions. But even is going in the same direction. So let's look at our last 3 examples. Describe the degree and the leading coefficient. So here we're going down and up. So we know our degree is going to be odd because it's going in opposite directions. And because it goes to the right up, we know that the leading coefficient is going to be positive. Here we're seeing an example of where they're going down. They're going down in the same direction. Or they're both going down, which is the same direction. So the degree has to be even. I suspect it's 4, but that doesn't matter. It's even, it's both going down, and the leading coefficient, because it's going down, it has to be negative. Here we have going up and going down. Do you see how this doesn't flow real smooth through here? I suspect that this is not a cubic. I bet this is to a 5th degree or bigger even. But that doesn't matter. We're looking at how they go in opposite directions. So the degree is odd. It's got to be a 3. It's definitely not 1 because it's not linear. It's got a lot of movement to it, but it's not real fluid, not straight. Not very smooth. It's got the extra little bump in there. So I'm sure there's an extra degree happening. So this could be a 5 if you wrote out the equation. But that part doesn't matter right now. We're leading coefficient. It's falling to the right, so we know it's going to be negative. Good luck, everybody.